I'm going to go ahead and assume that you already read our scenario up above, and we're going to jump into creating our gene map. So the first thing I did was I went ahead and I labeled our single crossover events, non-crossover, and our double crossover events. And the first thing I like to do is take both of our non-crossover events and put one on top and one on the bottom just to determine the gene order. Next, I'm going to use our double crossover events and ensure that they do indeed cross over twice. And that's going to confirm that I have the genes in the correct order. The next thing we're going to do is determine our map distances, which are going to be R1 and R2. And to find R1, that we're going to be using our first single crossover event. And that's going to be our single crossover plus our double crossover event divided by our total number of progeny times 100 comes out to be about 14 centimorgans. So looking at that first single crossover, it's going to go here and then cross over, here and cross over. So that means our distance for R1 is going to be right here, and that's 14 centimorgans. Next, we're going to determine R2, which we're going to be looking at our second single crossover event. So that's going to be the next single crossover plus a double crossover divided by our total, and then multiplied that by 100, and that comes out to be about 25 centimorgans. And if we go ahead and map that, let's choose purple. That means that we're going to be crossing over right there. So that means that our value for R2 is going to be in between here, which is about 25 centimorgans. And with this information, we were able to determine our coefficient of confidence, which came out to be approximately 0.83. And using that coefficient, that's going to allow us to determine the frequency of each of the events occurring. So let's go ahead and make some space here by erasing. All right, so to determine the frequency of our double crossover event occurring, we multiplied our R1 times R2 and then our coefficient of coincidence, and that came out to be approximately 3.03% when we multiplied it by 100, whereas our single crossover one event was our R1 minus our double crossover event, and we multiplied that by 100 to get a percent, which turns out to be 11.27%. So the probability of our double crossover occurring is going to be 3%, whereas the probability of our single crossover one occurring is going to be 11.27%.